Today's topic is fusion energy. We will calculate the energy that is released in a particular fusion reaction, that is when two isotopes of hydrogen, that is deuterium and tritium, fuse to form helium and neutron. In order to calculate the energy released, we will find the total mass of the final nuclei and total mass of the initial nuclei in atomic mass units. And you know that one atomic mass unit is equal to 931.5 million electron volt. The total mass of the final nuclei will be less than the total mass of the initial nuclei, reacting nuclei. This difference in mass is called mass defect and we denote it by delta M. Now let's see how we calculate the energy released in a fusion reaction when deuterium and tritium combine to form helium and neutron. Since the energy is released in this reaction, so the total mass of the final nuclei is less than the total mass of the initial nuclei. To determine the energy released, we find the amount in atomic mass units U by which the total mass has decreased. Now initial masses of deuterium and tritium are written here. We will find the total. Similarly, we will find masses of helium and neutron and find the total mass, and we will see that total mass of the final nuclei is less than the total mass of the initial nuclei. So mass of deuterium is 2.0141 unit and mass of tritium 3.0161. Total comes out to be 5.0302 units. So final masses of helium is 4.0026 unit and that of neutron is 1.0087. Total comes out to be 5.0113 units. So obviously this is less than the total mass of the initial reacting nuclei. Now what we will do, we will find the difference in mass of these two final nuclei and initial nuclei, which is called the mass defect, as I have told you already. So denoted by delta M, mass defect comes out to be a difference of masses between reacting nuclei and final nuclei. So it is 0.0189 unit. Since one atomic mass unit is equal to 931.5 million electron volt, therefore 0.0189 unit will be equal to 0.0189 unit times 931.5 million electron volt divided by one atomic mass unit. So after cancellation and multiplication of these two quantities, energy released comes out to be about 17.6 million electron volt. Since the deuterium nucleus contains 2 nucleons and the tritium nucleus contains 3, thus there are 5 nucleons that participate in the fusion. So the energy released per nucleon is about, it will be 17.6 divided by 5, which is about 3.5 million electron volt. This energy per nucleon is greater than the energy released in a fission process, which is about 0.9 million electron volt per nucleon. Thank you for watching.